Okay, so let's graph our first quadratic equation. We're going to graph f of x equals x squared. And so the key to what a quadratic equation is going to look like when you graph it is it's going to be either an upward or downward facing symmetrical U shape. One of the keys is to find the vertex, and the vertex is either the maximum or minimum point of the parabola. Now you'll notice that I have this table of values over here, and I've already put in the values for x. One of the keys here is for us to realize which one of these values for x will get us the vertex. And the way I want you to think of this is, since x squared will make any negative number positive, you can never have a value for f of x for this quadratic equation that would be lower than 0. So because of that, 0 will get us the lowest value we can get for f of x. So I'm first going to plug in f of 0, and I'm going to go ahead and get my vertex, which is 0 squared, which is 0. So my vertex here is going to be 0, and I'm going to put a big V there because that's going to be my vertex. That's going to be the point around which the U shape will form, both to the right and to the left. Now when I move one unit to the right and to the left, and I'll get the same value, I'm just going to do one of them. I'm going to do f of 1. I get 1 squared I'll get 1 squared, and that equals 1. If I had put negative 1 in there, I would have been negative 1 squared. I also would have gotten 1, so I'm going to put positive 1 for both of those. So that would get 1, and that would get 1. Let me use the same color. And so I've got 3 points already. Then I'm going to do f of 2, which is the same thing I would get for f of negative 2, and I'll have 2 squared, and I'll get 4. Then I'm going to do, so I'll get for both 2 and negative 2, I'll get 4 and 4. And for f of 3, I'll get the same thing as I get for f of negative 3, since it's negative 3 squared, and I'll get 3 squared, which is equal to 9. So I'll get 9, and that's enough points to graph. It's going to be, as I said, a U-shaped, it's a curve, so it's not just connecting dots, so it's not just connecting segments here, it curves. So I'll try to draw that as best I can. So here is 0, 0, and maybe I'll go a little darker here for this part, and then 1, 1, and negative 1, 1, and then I'll go 2, 4, right there, negative 2, 4, and then I'll go 3, 9, should be right, 2, 5, 6, 7, 8, 9, right there, and the other one's over here. So change my, so then I'll get so to look, and I make it curvy. I never have it go straight up. That's not how it works. It's still widening out, but so it looks a bit like this. and I'll show it to you in the calculator and with the calculator in class. There's your first graph of a quadratic equation. That's called a parabola. Alright, so we're going to go down below here. One other thing I wanted to add is that our axes will be, this is now instead of your y-axis, your f of x axis. And this is your x-axis over here. Now we're ready to go down below. So let's go ahead and label this one as well. So that's f of x. That's your old y-axis. It's the same thing really, just using function notation. And that's your x-axis. So, if I have f of x equals x squared minus 2. Now what this is going to do, now instead of 0 being the lowest point I could get for y, now because of this negative 2, the lowest value I can get for f of x is negative 2, and that's going to be my vertex point. So I'm going to put negative 2 here, and that's going to be my vertex. Now what value for x gets me negative 2? Well, it's going to be 0, because anything else that I would plug in there, would get into x would get me a higher value for f of x, because when I square whatever value I have for x, it's going to get a positive number if I choose something other than 0, whether it's positive or negative. So f of 0 is going to be my vertex, because that's going to be 0 squared minus 2. So anything else I use for x will generate a higher value for f of x than negative 2. So I'm going to continue to move 1 on each side of 0. I'll go 2, 3, and again I only need to calculate one value for x, because there's a second value for f of x that's the same because of the squaring of the x. So let me slide up just a little bit. So if I do f of 1, remember that f of negative 1 will get me the same f of x value, so f of 1 will get me 1 squared minus 2, so I get 1 minus 2, or negative 1. And remember, if I had substituted negative 1 for x, I would have also gotten 1 minus 2, or negative 1. Then I'll do f of 2, and that's 2 squared minus 2, so that's going to get, remember this was negative 1, let's put that, and this gets me 4 minus 2, or 2, so that's 2, and that'll be 2 as well. And then I'm going to go f of 3, which will get me the same thing as f of negative 3, which will be 3 squared minus 2, so that's 9 minus 2, so it's 7. So what really happened, this is going to be the same graph, except there was a shift down by 2 units, so it's going to look very similar, except it's just been shifted down by 2 units, so that minus 2 had the effect of shifting the parabola down 2 units. So 0, negative 2 is my vertex. I'm going to get a thicker point here. So 0, negative 2 is right here. Then I've got 1, negative 1, and negative 1, 1. Then I've got 2, 2, and negative 2, 2, and then I've got 3, 7, and negative 3, 7. So that again looks very, very similar, just is moved down 2 units. Okay, so let's go to the next page. All right, so the next one you might be able to guess is going to be, so if minus 2 caused it to be lowered by 2, plus 3 would mean it's going to be raised by 3, and that's exactly what's going to happen. So I'm going to go pretty fast on this one since it's so similar. So my vertex this time, the lowest value that x could be, that f of x could be, is 3. And so I'm going to go on each, so what would generate, again, it would be 0 that would generate, that's going to be my vertex. And then I'm going to move on each side of 0 to generate other points. So if I go f of 1, and that'll get me the same as I get when I do f of negative 1. So that's 1 squared plus 3. So f of 1 equals 4. F of 2, which will be the same thing as f of negative 2, will be 7. And then f of 3, which will be the same thing as f of negative 3, will be 3 squared plus not 7, sorry, I made a little mistake over here. And this should be 3 squared plus 3. So that is going to equal f of 3 will equal, let's see if I can move this up, f of 3 will equal 12. So let's go ahead and put those in there. So f of 1 is 4, f of negative 1 is also 4, f of 2 is 7, 7, and I have 12 and 12. So let's graph those. 0, 3, so that's all the way up here. Notice I moved my x-axis down. May label that. Always important to do that. And then I've got 1, 4, and negative 1, 4, and negative 2, 7, and negative 2, 7, and then 3, 12, and negative 3, 12. And that's going to be right over here. Let me move this a little bit. Make that a little smaller because my point's going to be right there. So I'll make that just a little bit smaller. And then my point is going to be right there. So let me draw my parabola now. There's a nice curve, slightly widening out through the points, slightly widening out. So there's your parabola for that one. Okay, so let's slide up. Now you'll notice that this time I have a number being added inside the parentheses, and we got to discern what effect that has. Now this time, because the number is inside the parentheses, I can get a value of f of x that is equal to 0, and then it's not possible for me, because of the squaring here, to get a value for f of x lower than 0, but there's a value that gets me my lowest value for f of x that is 0, and that value for x is -2. So I'm going to write -2 here. Again, you just have to think this through, that because everything's getting squared on the right side, there's the value that's going to get me the lowest value for that expression is going to be -2, because it's the opposite of 2, and that's going to get me a 0 in the parentheses, because everything else I'll put in there, whether negative or positive, will, when it gets combined with adding 2 and then squared, it's going to be a value above 0. So let me go ahead and label my axes here, get that little detail taken care of. Now, since our x is not 0 this time, we're going to move on each side of -2. So I'm going to go on the positive side. I'm going to go to -1, and on the other side I'll have -3, and I'll have, whoops, that's going to be 0. And I'll have 0. Let me just go like 0 and 1, by the way, and then -4, -5. That'll get me 3 points on each side of the vertex. That usually gives it a nice shape. And so let me also label my vertex. So this is my vertex point right here. And so let's do f of -1 will be the same as f of -3, and the reason that is because when I add -1 to +2 and square it, I'll get +1 squared, which is 1. And when I do f of -3, I'll get -3 plus 2, or -1 squared, which is also 1. So each of these gets the same value for f of x. Now then I'm going to do f of 0, and I'll get, see, 0 this time doesn't get me the minimum value like it did in previous problems. 0 plus 2 is going to be 2 squared, or 4, and that's going to get me the same value as -4 does, because when I plug in -4, I get -4 plus 2, or -2 squared is also 4. And then let me plug in f of 1, which is 1 plus 2 squared, so that's 3 squared, or 9. So I get 9 and 9 for those. So let's go ahead and graph this. So again, this time my vertex is not at, it's actually on the x-axis over here at -2, 0. So that had the effect of shifting things to the left by 2, not up or down, but left by 2 when there was a addition or subtraction inside the parentheses. Then I've got -1, 1 and -3, 1, and then I've got 0, 4, -3, 4, and I'm sorry, -4, 4, and then I've got 1, 9, and -5, 9. So we'll draw this parabola now. There it is. All right, let's go to the next one. Okay, we can go to the next. So on this one I have f of x equals x squared plus 2x, so even a little different on this one. So this one is a little more complicated. So this time what I have to do to get in a form where I can tell where the vertex is, I have to complete the square, but I got to do it in a little bit of an odd fashion. So what I have to do is so the way I do this is, since I don't have 0 on the other side, I can't just add the same amount to both sides. I've got to do this little almost artificial technique. I've got to add the amount to complete the square on the right side, and then I've got to add its opposite so that I'm not changing the equation. So this is going to seem strange, but this is what you do. So I'm going to complete the square. So I'm going to say f of x equals, let me actually move this over. I'm worried I'm going to run out of room here. So I'm going to have f of x equals x squared plus 2x. Now I'm going to add half of the 2 and add it to both sides, and I can't add it to both sides. I'm going to add, so half of 2 squared is 1, 1 squared is 1. But so as not to change the equation, I'm going to also subtract 1. Now, so what that means is I now have so what I want to do, since I completed the square, this part of it is a trinomial square, so I'm going to factor that, and that's going to be x plus 1, the quantity squared, minus 1. So now that I have that, I can tell what the vertex is. If you remember on the previous problem, when I had an x plus 2 in there, that meant that the vertex shifted to the left by 2 places. So actually it would seem, if you'll remember, when I had x plus 2 in here, it actually shifted it left because the value for x that makes me able to have my minimum point is actually the value that makes 0 inside the parentheses. So my x value that's going to get me my minimum point is going to be -1. That's going to get me 0 inside the parentheses. Otherwise, because of the squaring, I'm going to have positive values, and that will cause points to be above where this point is. So when I have -1 in for x, so when I have f of -1, and this will be my vertex, I have -1 plus 1 squared minus 1, so that's equal to 0 squared minus 1, so my f of x value at the vertex is also -1. This is my vertex. You'll see that no matter what else I plug in for x, I won't be able to get a f of x value below -1. So I'm going to go on each side of my vertex. I'm going to go up to, well, shoot, I'm going to not have a negative there. I'm going to have 0, 1, 2. And over on this side, I'll have -2, -3, -4. So let's go on each side. F of 0 would be very easy to figure out. F of 0 equals 0 plus 1 squared minus 1, so that's going to be 1 squared, so that's actually going to be 0. Then I'll do f of 1, and that will equal, and you could actually plug into the original equation if you want, whatever's easier for you. Then I'll have 1 plus 1, so that's 2 squared minus 1, so that's going to be 3. So f of 1, and that'll be the same value, by the way, that I get for -3. So that's -1, and then f of 2 is equal to 2 plus 1 squared minus 1, and that's 3 squared, so that's going to be 3 squared minus 1, so that's 9 minus, so f of 2 equals 8. So remember, the 0 value is going to get the same as the negative 2 value, and that's going to be, so 0 is 0, negative 2 is 0, 1 is negative 1, sorry, 1 is, I made a mistake there. That's going to be 2 squared minus 1, so that should be, so 2 squared is 4, so that should be 3, right? That doesn't make sense that we would have a negative 1 there. So that's going to be 3, and that would get you the same as if you plugged in negative 3, because negative 3 plus 1 is negative 2. Negative 2 squared is 4. 4 minus 1 is 3. And then we had f of 2 is 8, and that's the same as negative 4 would get if you plug that in. So there we have. So let's go ahead and graph these. So our vertex is at negative 1, which is right there. I was going to change that, put that in green. And then you have 0, 0, and negative 2, 0. You have negative 3, 3, and 1, 3. And you have 2, 8. And negative 4, 8. Draw our parabola now. There it is. Okay. So let's go to the next one. So the next one I'm going to graph, if f of x equals negative x squared. Let me go ahead and label my axes. So this is the first one we've seen where we have a negative before the x squared, and that's going to have the effect of having the parabola turn upside down. All right. So now what we're looking for at our vertex is the maximum point for f of x. And again, because things get squared, that negative, after I square something, is going to make everything negative. The only thing that can't be negatives is if I have a x value of 0. If I have an x value of 0, that's the only place where I can get anything that's not negative. So 0, 0 is going to be my vertex. Then I'm going to move on either side of 0, and when I do that, instead of everything being positive this time, no matter what I plug in, positive or negative, for x, the f of x will have to be negative. So when I plug in f of 1, by the way, that'll get the same thing because it's the negative of 1 squared, so that gets me negative 1. That'll be the same as I plug in negative 1. I'll still get a negative 1. So negative 1, negative 1. Then if I plug in f of 2, that's the opposite of 2 squared, and that equals, that's going to be negative 4. So negative 4, negative 4. And when I plug in f of 3, I'll get the same thing as when I plug in negative 3. That's negative 3 squared, the opposite of 3 squared, and that would get me negative 9. Same thing if I plug in negative 3. So that's going to look like this. And so I'm going to go 1, negative 1, negative 1, negative 1, 2, negative 4, negative 2, negative 4, and then I'm go all the way down here to 9 and draw my parabola. Okay, next page. Okay, now I'm going to graph the opposite of x squared plus 4x. That negative is going to cause this parabola to turn upside down. So it's also going to just make things tricky in terms of figuring out what the vertex is. But I've got to complete the square again, so I'll do that over here. So I've got f of x equals negative. Now I've got to complete the square here, so I've got to take half of 4 and square it. So half of 4 is 2, and I square it is plus 4. Let me erase that and move this over. Now here's the tricky part. I just added 4 to complete the square, but because that negative is on the outside, what I've really added is negative 4, so I'm going to actually have to add another 4. And that's because when I completed the square inside the parentheses, the negative on the outside really means what I've added to this side of the equation is a negative 4. So even though I completed the square with a positive, I've really added negative 4, so I had to add a positive 4 in order to make sure I haven't changed what the equation is. So now that gives me, so I'm going to factor the expression inside the parentheses, and that's going to be x plus 2, the quantity squared, plus 4. Now what's going to happen is, in terms of figuring out my vertex, this plus 4 means that everything is going to be shifted up 4. But my minimum value, the way I can get my, actually it's because it's a negative out front, I need to get my maximum value for f of x. What will get me my maximum value for f of x will be if I make x negative 2. That will get me 0 here, and so that makes 0, 4 the highest value that f of x could be. So I'm going to put a negative 2. So I'm going to put a negative 2 in for x. This will be my vertex. And what negative 2 will get me, f of negative 2, when I plug in, will be the opposite of negative 2 plus 2. So negative 2 plus 2 is 0. 0 squared is 0. Negative 0 is still 0 plus 4. So 0, 4 is my, or negative, I'm sorry, negative 2, 4 is my vertex. So negative 2, 4. Now every other point we would want to have will be below that point. And it all has to do with that negative being over outside the parentheses of the expression being squared. So negative 2, 4 is the highest value for, it's the point that gives the highest f of x value, the maximum point. Then I'm just going to move on either side. I'll move the positive side, and then, I'm sorry, that should be 0. 0 and then 1. And then over here, negative 3, negative 4. As long as I move the same distance on each side of the vertex, I can have these symmetrical pairs. So then I'm going to have f of, so let's start with f of negative 1. That's going to equal the opposite of negative 1 plus 2 squared plus 4. And that's going to mean, so what that ends up getting is negative 1 plus 2 is 1. 1 squared is 1. And negative 1, that ends up getting plus 3. And I'd get the same value for negative 3 because I get negative 1 inside the parentheses, and that gets made to be 1, but then negative 1 plus 4 is still 3. And then I have f of 0. That's easy to figure out because I go the opposite of 0 plus 2 squared plus 4, so that ends up being 2 squared, or which is 4 next. That ends up getting 0 also. So f of 0 equals 0. And I get the same thing for negative 4. And then f of 1 equals the opposite of negative 1 plus 2 squared plus 4. So that ends up getting me 1 inside the parentheses, so that's 1 squared, so that's negative, let's see, sorry, I need to plug in a positive 1 there. So when I plug in a positive 1, that gets 3 squared, which is 9, which is 3 squared, which is 9, but then that gets made negative, so negative 9 plus 4 is 5, so that's going to get 5, so that sounds right. I'm sorry, negative 5. Okay, so I think we've got everything. So f of 1 gets the same thing as f of negative 5, which is negative 5. All right, so let's go ahead and graph this. And so I've got f of negative 1 is going to be 3, and that's going to get the same thing as negative 3. So that gets there, and then 0, 0, and negative 4, 0. You can see these points are forming symmetrically around the vertex. We also call it the axis of symmetry. I'll talk more about that in class, just try not to give you too much right now. And so there's the parabola. I used a thick marker. I'll draw my points back in a second. So my points were there, 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 and there. Okay. All right, last problem. So this last one we're going to do is f of x equals x squared plus 6x plus 9. Now this one should go pretty fast because I want you to notice this is already a trinomial square, so we won't need to complete the square. So I'm going to go ahead and factor that, and that will be f of x equals x plus 3, the quantity squared. So if I have f of x equals x plus 3, the quantity squared, that means that whatever I make for x to make this equal to 0 will get me my minimum point, or the vertex on the parabola, so that will be f of negative 3. So I will get negative 3 plus 3 squared, so f of negative 3 equals 0, because it's negative 3 plus 3 or 0 squared. And so that's my vertex at negative 3, 0. And otherwise, this will just end up looking like the very first graphs we did. I'm going to go up by 1 and down by 1. And so when I make, I go f equals f of negative 2, so I make x negative 2. That will be negative 2 plus 3 squared, and that will be f of negative 2 equals, that's 1 squared, or 1. And I'll get the same one for negative 4. When I do f of negative 1, I'll get negative 1 plus 3, which is 2 squared, or 4. And then, so when I do f of 0, that'll get me 0 plus 3 squared, so that's f of 0 equals 9. So I've got 4 and 9 and 4 and 9. So again, this is just really like the very first graph we did, where it starts on the x-axis, except it's slid over 3 to the left. It's got a horizontal shift to the left. So I've got 0, a negative 3, 0, and then I've got negative 2, 1, and negative 4, 1, and then I've got negative 1, 4, and over here I've got negative 5, 4, and then I've got 0, 9, and I've got negative 6, 9. So that makes my parabola look like so. And that's the end of the lesson.